Good afternoon, everyone. I just want to go through today's lesson and just have a quick smartboard lesson, and I'll post the video along with the completed notes and the assignment for the next couple of days. So give me a couple minutes here. We'll get rolling here. And we are working right here. So, all right, so we're going to get started on this section. This is going to be a very quick lesson for everyone today, and it's on a couple things.
Madison Linder to the office, please. Madison Linder, please come to the office. And remember, tonight there will be an FFA meeting at 7 p.m. in the high school commons, and middle school yearbook will meet tomorrow after school in the yellow lab. And seniors, remember, tomorrow will be the start of the senior pictures. Tomorrow will be for the B group. They'll take place outside of the bleachers at 8.
Okay, sorry about that. I forgot the announcements were coming on. So today we talked about two key ideas. We are in 4.2, so chapter 4, section 2, extension.
And the Recording Student Senate will be planning a virtual variety show on coronation to celebrate homecoming.
Okay, here we go again. Parallel lines and slopes and perpendicular lines and slopes. This is an extension, a quick little video on this, and hopefully it's helpful for you. I got the completed notes also on Teams. Okay, so the first thing is with parallel lines. Parallel lines have the same slope. Okay, so when you're talking about two lines that are parallel, they basically will never intersect. So any non-vertical parallel lines have the same slope. So let's take a look. This is what you're going to be looking to do. So just keep in mind we're looking for the same slope. Same slope. All right, this is the first type of question you're going to be asked in this. You're given 3 lines, line 1, line 2, and line 3. And what you're asked is which out of the 3 lines are parallel. So, you know, you don't want to eye them up. We actually have a process of doing this. We find the slope. So over here, what I'll do is I'll put together a little table, and what I'll have is line 1, line 2, and line 3, and I'll have here the slope. Okay, I'm just going to use rise over run. You could use the formula if you wanted to, but for the sake of this, we're going to use rise over run. And if you have any questions, just reach out to me on this. But these are all positive slope lines going uphill from left to right. So this first line, it's going to have a slope of 1, 2, 3, 4 is the rise, and the run is 1, so the slope is 4. Line number 2, we're going to start at this point, 0, -2. I'm going to end at 1, 3. So I'm going to go up 1, 2, 3, 4, 5, and I'm going to run 1. So that's got a 5 over 1. And line 3, I'm going to go up 1, 2, 3, 4, and I'm going to run 1. So I have a slope of 4. So based upon this exercise here, finding the three slopes of these lines, I can conclude that lines 1, line 1, and line 4 are parallel. How do you know? The slopes are the same.
Emma Klein to the office, please. Emma Klein, please come to the office.
So keep a lookout for those types of questions on today's worksheet. The second item today is going to be called perpendicular lines. So there's a relationship with the slope of the line and perpendicular lines. So basically perpendicular lines, they form a perfect corner. Okay, they form a perfect corner. You notice this little note here. They've got a corner drawn into two lines. That's considered perpendicular. And you see that all the time. And basically with perpendicular lines, what we have is opposite reciprocal slopes. So you want to write that down. Opposite reciprocals. I think I spelled that right. Opposite reciprocal slopes. So let's just kind of walk through this little exercise on what it means to be opposite and what it means to be reciprocal. So let's just say hypothetically I have two lines. I have a blue line, or whatever color that is. I know I struggle with colors. And let's say over here I have a green line. Okay? And that green line I have a slope line. I think that's mint, maybe. I'm not really sure. But let's say that you have these two lines are perpendicular. These two lines are already perpendicular. Okay, so we're told that they're perpendicular. And what we're going to do is just put a few of these sloped lines out. Like let's say we have a slope of 2, a slope of 1/2. Let's say we have a slope of -3/7 and a slope of -4/5. Okay, so what it means to be perpendicular and opposite reciprocals would basically mean that if you had a slope of 2, you would also, on the opposite reciprocal line, you would have a slope of 1/2, and it would be -1/2 because this slope is +2. The opposite of positive is negative. The reciprocal of 2 is 1/2. So the same thing with 1/2. If you have a slope that's 1/2, the reciprocal of it is 2/1, and then the opposite of positive is negative. Okay, so we're looking for opposite reciprocals with perpendicular lines. So if you had a -3/5, let's call it, it would be a positive 5/3. And if you had a reciprocal of 4/5, it'd be 5/4, and it would be a positive 5/4. So these all are examples of lines and slopes that have opposite reciprocals of it. Okay, so you got to think of the reciprocal, and you think of it the opposite. So positive would be negative, negative would be positive. Okay, let's go through the examples here on this next problem. This is the type of example that you're going to be asked to do. You are given 3 lines, okay? And with these 3 lines, you're asked a simple question. Which of these 3 lines, which 2 are perpendicular? Okay? You can't just go and eye it up. You actually have to find the slope of all 3 lines, and based upon that slope, determine which 2 are perpendicular. Let's give it a try. Let's call this line 1. Let's call this line 2, and let's line 3. You know I struggle with colors because I'm colorblind. So let's just leave it at that, and let's make a little grid over here, okay? So if we have line, column, and a slope column. Okay, so I'll call this line 1, this is going to be line 2, and this is going to be line 3, all right? So line 1 has a negative slope, it's going downhill, okay? and it's going to go down 2 units, and it's going to run 1, 2, 3, 4, 5, 6. So it's -2.6, which is equal to -1/3. Line 2 has a slope of -1, 2, and then it's got a run of 1, 2, 3, 4, 5, 6, 7. So that slope is -2/7. Now, this is where the rubber meets the road. Line 3, okay? Line 3, just going to get that out of the way. Line 3 has a slope of, it's going to be positive slope. It's going to go down 1, 2, 3, 4, 5, 6, 7, then over 2. 1, 2. So rise of 7 over 2, and it's positive. Okay? So based upon this evidence of slope, we have ourselves lines 2 and line 3 are perpendicular. So if you're in need of some extra help with slope, this is going to be a nice little lesson for you today, because you do a lot of calculation with slope. You could do the numbers way. We've got these nice grids. We're just using rise over run. And let's look at one more example on an exit ticket. Okay, one more example would be this type. Which lines are parallel? Which lines are perpendicular? So we have 4 different lines, and I'm just gonna zoom into this a little bit more. So we've got this nice quadrant 1 through 4 here with these four lines. We're going to label them line 1, line 2, line 3, and then this is line 4. Okay? So if I find the slope of all 3 of these lines, I will tell the following: which 2 are parallel, and which 2 are perpendicular. Okay, so which 2 are going to be parallel and which 2 are perpendicular? All right, let's look at line 1 first. I've got 3 positive slopes. Line 1 is positive, line 2 is positive, line 3 is positive. 4 is going to be negative. Okay, so let's put a little negative there. It's a downhill slope from left to right. Okay, so let's go ahead with number 1. We're going to go, all these are increments of 1, so we're good to go. I'm going to go up 2 over 1, 2, 3, 4, 5, 6. So again, up 2 over 6. So that's 2/6 or 1/3. Okay. All right, let's move on to line number 2. Line 2 goes up 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, 7, 8. So it's 4 over 8 or 1/2. Again, it's positive. Line 3, up 2 and over 1, 2, 3, 4, 5, 6. So up 2 over 6. And that'd be 1/3. So you already answered your first question, which 2 are parallel? And it appears that line 1 and line 3 are parallel. line 1 and 3 are parallel. Okay, so now we're looking for this perpendicular relationship. And this is where we're going to have a negative slope line. We're going to go down 1, 2, 3, 4, 5, 6, 7, 8. Then we're going to go over 1, 2, 3, 4. So we're going to rise of 8, run of 4, which is equal to 2, and it's a negative 2. So you can see here that lines 2 and 4 are perpendicular because they're opposite reciprocals of each other. So that's the exit ticket today. Parallel 1 and 3, perpendicular 2 and 4. 1/2, the opposite reciprocal of 1/2 is negative 2. So this lesson basically covers slope and a special relationship with parallel lines having the same slope and perpendicular lines having opposite reciprocals. I hope you found this helpful because I'm going to attach a small worksheet on there, and you have the worksheet already. It is in your journal, and it is going to be pages 31 and 32 in your journal, I believe. Okay, so it's in your journal, page 31 and 32. You're going to do them all, and if you are going to be turning it in, you're going to want to turn it in to me in a chat. Okay, so send it to me in chat, and I will make sure it is send a copy of it. It's page 31 and 32 in your journal. Hope this was helpful, folks, and I hope to see you guys soon. Take care and have a great day.